So today we're talking about factoring a particular pattern. Before we talk about that pattern, we want to take a look at these guys. Okay, so if you have like x minus 3 times x plus 3, and you want to multiply them together, let's multiply them out. Okay, so I have x squared, and then I have plus 3x, and then I have minus 3x, and then I have minus 9. And you guys see how the plus 3x and the minus 3x, they cancel each other out, just like how we did the conjugates. So they cancel, and so you have just x squared minus 9. Okay, so x squared minus 9, when you factor that, that becomes x minus 3, x plus 3. You factor that, okay? And same thing if you have like x minus 4 times x plus 4. When you multiply them together, the middle terms cancel each other, you know. So you have just x squared, and the last term is negative 16. Okay, so that's the pattern that we want to memorize, basically, so we can factor them. We're just going backwards, right? So an example would be x squared minus 49. You know, how do you factor that, right? Factor. So if you do this, you have just x, like, so you want to make sure that this is a perfect square, and you want to make sure that this is a perfect square, right? And then you want to make sure that that's a subtraction, okay? That's why they call it a difference of squares, is you have a square here, and you have a square here. Perfect squares, okay? So perfect squares and a subtraction in between. So when you factor that, you should have just the root of this, the square root, which is just x, and then the root of this, which is just 7. So you have that here and there, and one of them is a subtraction, one of them is a plus. So when you multiply them together, they can cancel each other out. Okay, so let's do another. I have x squared minus 25. Again, this is a square because it's x squared, and this is a square because 25 is a perfect square, and that's a subtraction, so it's all good. So now I just factor that. I have a square of this, a square of that. Same thing here. And one is a plus, one is a minus. Okay, it doesn't matter with the order. And that's it. So when you see a problem like this, x cubed minus 9, can you factor like that? You can't, because this is not a square. The exponent is not even. Okay, so it's not a square. So you can't do it. You have x squared plus 100. Okay, can you factor that like this? This one you can't either. Okay, why? Because look, this is a square. This is a square, but this is not a subtraction. It's a plus sign. You can't do it. Okay, so you can't do that either. Let's look at another type. Say I have 5x squared. Whoops, 5 would not work. If I want 9x squared minus 25. Again, you have to look at this whole thing. Is it a perfect square? And then you look at this whole thing. Is it a perfect square? And is that a subtraction? Well, okay, that's good. This is good because I know that's 5. Is this a perfect square? To find out, you just have to root the number and root the x. Okay, so the root of the number is 3, and root of the x squared is x. So that works. Okay, so I can have 3x here, and then you have 5 here, and 5 here, and you have a subtraction and a plus sign, and that works. All right. Another one, I have 4x squared minus 100. Okay, is this a perfect square? Yeah. And you can root the number, which is 2, root the x squared, which is x, and then root 100 is 10, so 2x and 10. One of them is a plus, one of them is a minus. All right. The last type is when you have something like this. So you have 5x squared minus 49. Look, this um, is that a perfect square? Oh, I used the wrong number. So 45, not 49. But here, look at this one. It's not a perfect square because 5 is not a perfect square, right? So already we know that we can't factor like that. But you always, always do what? The GCF first. So before you do anything else, you should really do the GCF first. So I actually can take out a 5 from both of them. And take out 5 here, I have just x squared left. I take out 5 here, I have 9 left. You see how now this is a nice perfect square. See? Square and square. So I have 5 outside, and then I have these guys. So x minus 3, x plus 3. Okay, so always try to take out the GCF first. Okay. No matter which factoring you're doing, you always take the GCF first. So I'm going to do another. Okay, so 40 is not a perfect square. 1,000 is not a perfect square, but I can take out 10 from both of them, right? And then I have 4x squared minus 100. But this 10 is not a GCF because I can take out more. I can take out another 4. So I take 4 out, so I have 40 outside. And now I have just x squared minus 25. See, now I have these guys, which can be factored into 40, x minus 5, x plus 5. All right.